Hello everyone. In this video lecture, let us discuss about the topic block diagram model under unit 1 of control systems. Objective. The main objective of this video lecture is to introduce the elements of a block diagram model and their representation. So what is a block diagrams? So a block diagram is a pictorial representation of the functions performed by each component and of the flow of signal. So what are all the elements are presented in block diagram? So for having three elements, one is a block and summing point, branch point. So block is nothing but this one. So summing point here, this is a takeoff point. The block is having a signal is, input signal is RFS and output is HCFS. So next I will explain one by one in detail. So what is a block? In a block diagram, all the system variables are linked to each other through functional blocks. The functional block or simply block is a symbol for mathematical operation on the input signal. So to the block that produces the output, the transfer function of components are usually entered in the corresponding blocks, so which are connected by the arrows to indicate the direction of flow of signal. So the arrowhead pointed towards the block indicates the input. So and the arrowhead leads away from the block indicates the output. So such arrowhead refers to as signal. Such arrowhead is refers to as signals. The output signal from the block is given by the product of the input and transfer function in that block. So C of S is nothing but G of S into R of S. Next one is the summing point. The summing point is either add two signals. The summing point is used for either add two signals or more signals. So suppose the plus or minus sign at each arrowhead indicates whether the signal is to be added or subtracted. So next one is a branch point. A branch point is a point from which the signal from a block goes concurrently to other blocks or summing points. So next, this is the input and output relationship of linear system is given by its transfer function. So this is the transfer function of the block. So C of S is the output, R of S is the input. So what is the C of S? So the input signal, the product of input signal into transfer function of that block. So that R of S into G of S. So next one is when the blocks are connected in feedback. So how it is simplified in a block diagram reduction technique. So this is here R of S is the input signal, C of S is the output, the G of S is the transfer function of this block, and H of S is the transfer function for this block. So here this is the feedback block. So here the output of this one is B of S. Here the E of S is nothing but the error signal. So the difference between R of S and B of S is nothing but E of S. So now we can write the equation for E of S. So E of S is equal to R of S minus H of S into H of S into C of S, because H of S into C of S is nothing but B of S. Okay. So now C of S is nothing but E of S into G of S. So you can substitute E of S in the above equation so that C of S is equal to R of S minus H of S into C of S. Okay, this is C of S. So you can take outside for C of S. So 1 plus G of S into H of S equal to R of S into G of S. So now what is the transfer function? C of S by R of S. So equal to G of S by 1 plus G of S H of S. Whenever the feedback element are presented in your block diagram technique, so you can directly put G of S by 1 plus G of S into H of S. Next, when the blocks are connected in series, that means cascade. So how it is reduced for that block is, so having here I am taking 3 blocks are connected in series or cascade. So G1, G2, G3s are connected in cascade. So what is the output for this one? The product of these two. Similarly, for output of this one is the product into this signal. So output of this one is the product into this one signal. Okay. So finally, we can C of S is nothing but G3 of S, G2 of S, G1 of S into R of S. So R of S, you are giving input signal. So C of S is the output signal. The remaining terms are put it in a transfer function block. So you can simplify 3 blocks into 1 block. So that is a procedure for whether the cascade connections are presented. Okay. Next one is for parallel connections. So all the 3 blocks are here is taking as a parallel. So R of S is the input signal. So what is the signal here? X1 of S is R of S into G1 of S. X2 of S is R of S into G2 of S. X3 of S R of S into G3 of S. You can take the addition of all the signal, that is C of S is equal to plus or minus G1 of S plus or minus G2 of S plus or minus G3 of S into R of S is a common. Okay, you take it as outside. So now what is the R of S is nothing but input signal. C of S is nothing but output signal. So in this block, transfer function is plus or minus G1, G2, G3. So here input is this one. Whenever the parallel connections, so all the transfer function, that is means individual transfer function values are add or subtract depending upon the summing point values. Okay. So now R of S, here the C of S. Next one is the block diagram algebra for summing junction. Say for example, first one is I am taking the summing junction into after a block G of S. Okay, summing junction after a block G of S. So how will you change it for this one is equivalent for this one is, so you can add the corresponding summing value, you put 1 G of S. So what is the, you can here is what is the C of S? C of S is equal to G of S into common factor G of S is, take it outside. So R of S plus or minus X of S. So now here what is this? R of S into G of S here. So and then X of S into G of S. Okay. So we take it outside for G means R plus X. So both are same. So similarly for next one is the moving point before the block. The moving point before the block instead of this, sorry, moving point, not some moving, the summing point before the block. So here I am changing the summing point before the block G of S. So you put 1 by GS for the corresponding branch. Okay, corresponding branch. Here I am putting 1 by GS. So what is the C of S now? C of S is G of S into R of S plus X of S. Okay. So because these two, multiply these two means that will be cancelled. So you take it outside for G. So R plus or minus X into X by G. Okay. Next one is the block diagram algebra for branch point. That is when a branch point ahead of the block, so that you can add the particular branch 1 by GS. Whereas in the that is before the block, the branch point moving before the block means you add only for G of S. Next one is the block diagram reduction rules. This table represents the steps to be followed when combining all the cascade blocks first and then combine all the parallel blocks, eliminating all minor feedback loops, shift summing points to left, shift takeoff points to the right. Repeat the steps for 1 to 5 until the canonical form is obtained. So next one is all the 6 rules are summarized in this table. Next, some of the examples for block diagram reduction technique. The first examples are all the blocks are in cascade or in series. You know already our reducers for in a single block means you take the transfer function for each block, multiply that blocks, and then you put the input and then output. Okay, so here the input value is theta 1 of s, output is theta 4 of s. So what is the transfer function for this block is G1 of s, G2 of s, G3 of s. This is the transfer function for your given problem. Next one, move on to this one. So here look at this diagram. So having this diagram, the block diagram, so just having feedback, simply feedback. So eliminating the feedback rule, so you can use that one. So G of s by 1 plus G of s into H of s. This is where transfer function for this block. So next one is so having this clear feedback along with one cascade G1 of s, and then one feedback is presented. So first you can reduce the initial feedback element. So that reduces this one means G2 of s by 1 plus G2 of s into H of s. So after that you can combining these two elements are in what is a parallel. So combine these two. So and then reduces that one means eliminating the feedback part. So which is given by G1 of s, G2 of s by 1 plus G2 of s H of s plus G1 of s into G2 of s. Next, the fourth problem. Here this one is the fourth problem. So will you eliminate for this one is first step interchanging the blocks. There is a interchanging the branch point after G3. First step. So in this branch point I am shifting here. So you know the branch point shifting after the G3 means you put 1 by G3. Okay, 1 by G3. So instead of H of s, you put 1 by H of s by H1 of s divided by G3 of s. Okay, so this is a reduced diagram after the interchanging a branch point after G3. So this step is applied for this one. So next one is a clear feedback is there. So and then this one is a cascade for that one. So and then next step I am eliminating the feedback path and combining the blocks in cascade. So that next the transfer function, the block diagram is this one. This G1 of s into G2 of s, G3 of s divided by 1 plus G2, G3, H2 of s. Okay. Next, this block and this block connected to the summer. So clear feedback is presented. So that eliminating the feedback loop. So you can simplify and write the transfer function for that block is G1, G2, G3 divided by 1 plus G1, G2, H1, G2, G3, H2 of s. This is our final transfer function of your block diagram. So next example 2. So the given problem, so the next one is the given example problem 2. So here in this problem, here the G1, G2, G3 and H is the feedback. Okay, KC are the KC, G1, G2 are the forward path and H is the feedback. Another G2 also here, one of the feedback. Here the X of S is the input signal and Y of S is the output signal. We can find the given problem for Y of S by X of S. Okay, so first step is you can eliminate the feedback path. So this one is the first eliminating feedback path. Here, what is the simplified for the summer? These two blocks, so that G1 by 1 plus G1 G2. So that is the elimination of feedback path. So G2 by 1 plus G1 G2. So here KC is presented and then G3. Okay. So the feedback is H. So you can notice this one. So how what is these three blocks are in cascade. Okay. Next step, you can eliminating the feedback loop. That means the combining this cascade. So having some one block is there. So that after that there will be having, say example, I can assume that as a G. So this one is H. This one is summer is there. So that this is a clear feedback. So first you can combining the blocks in cascade and then eliminating the feedback. That is the second step. So that the next step will be your answer for the transfer function for this block. So KC G1 G3 divided by 1 plus G1 G2. Okay. So along with H is the feedback element. So these elements are in what is this? G. You can assume G. So what is this? G by 1 plus GH. So after simplification, so the final transfer function for this one is KC G1 G3 divided by 1 plus G1 G2 plus KC into G1 G3H. So this is the final transfer function for the given problem. Say for Y of S by X of S is KC G1 G3 divided by 1 plus G1 G2 plus KC into G1 G3H. These are all the references I referred for preparing this video lecture. Thank you for watching this video.